Hi, welcome to GeekDIYMechanic Mechanic. The purpose of this video is to discuss a P0455 EVAP System gross leak detected error and a P0401 EGR insufficient flow detected. So let's start. Let's navigate to case studies and let's find Ranger, EVAP, and EGR DTCs. I thought, since you have this text you can read to help me explain what happened and maybe give a little bit of background, I'm going to leverage PowerPoint here, PowerPoint slides. So let's begin. A really good friend of mine who's very good with cars, we were just talking on the phone, and he brought up that his check engine light was on, and it was his truck, a 99 Ford Ranger, was idling a little higher than normal. So we thought it'd be fun to diagnose it together. So a couple days later, I stopped by, and obviously the first thing we did was pull engine codes, and these were the two errors that the scan tool picked up. EVAP gross leak and an EGR insufficient flow. And we decided to attack the EVAP leak first, and you'll see why. We had some suspicions on what happened. We thought that would be the easier of the two to attack, so we chose that one first. So let's give a little background what the EVAP system is before going into what we did. OBD2, the whole goal is to reduce the chemicals emissions from an engine into the atmosphere, to help keep our air clean. And I think it's done a great job, especially if you compare, let's say, to China, right? Anyway, and so as the car is moving, gasoline in the gas tank is producing vapors. When you fuel the car, it produces vapors, and as the fuel pump is cycling through fuel through the fuel rail for the injectors and back to the tank, for some systems, other systems are localized between either internal to the tank or between the fuel filter, but nonetheless fuel is being moved around, and that's going to produce vapors. In older cars before 96, not all, some of that vapor was released to the atmosphere, and that's not good. That's pure hydrocarbons, and it's not good for the environment. So the EVAP, Evaporative Emission Control System, was designed and spec'd out. So what the goal is to capture all those vapors in a charcoal canister. And then when the engine conditions are right, the system reintroduces those to the intake manifold so that those vapors are actually burnt with the air-fuel mixture. That way the hydrocarbon emissions are reduced tremendously. Well, clearly, for that EVAP system to work effectively, it needs to be a closed system. In other words, what a great system it would be if it had a big hole in it, and as it captured the vapors, released to the atmosphere. So clearly it has to be closed. It has no leaks. So OBD2 standard proposed that all of these emission control systems test themselves, and one of the tests in the EVAP system is it tries to detect if there's leaks in the system that's allowing it to leak to the atmosphere. And those sensor is so sensitive it can detect 0.02 of an inch a hole diameter. It's pretty small. And in our case, we have a gross leak, which is 0.09 diameter of a hole in the fuel system. Well, generally, the low-hanging fruit of a gross vapor leak is your gas cap. If you don't close that down securely, some of them click, some of them lock in place, or the the gasket in there doesn't sit quite right on that filler lip there, it can cause the EVAP system to trigger this error. So we went with that. So we cleaned it with brake clean on a rag. We cleaned the lip of the filler, and then we cleaned the gasket in the filler cap and reinstalled it. And the reason we thought this was it is his teenage son drives the truck frequently and might have been in a hurry and left that open. So we went with that one. We executed, once we did that, we executed Ford's key-on engine running self-test. We used the bidirectional tool to start it, and it gives you some instructions: rev the engine, turn the wheel, turn on AC, turn off AC, push on the brake. If you have a clutch, you'd push in the clutch pedal at certain times. We did that, but unfortunately that test only tests the purge solenoid. Doesn't really test a full test. So that we had to wait for the full readiness monitor. So again, the key-on engine running Ford self-test really just looks for hard faults. Like I was saying, the key-on engine running test doesn't thoroughly test, doesn't execute all the OBD2 tests. So we knew we had to wait for the readiness monitors to execute. And in this case, we got lucky. We went with low-hanging fruit. Most probable was this. That tends to be what causes the gross leak. Doesn't have to be. There's other ones. And after several weeks, the DTC did not return. So we consider this a fix. But at that time, we didn't know, but we had a burning suspicion that was it. So we then moved on to the EGR issue. Again, that's the EGR insufficient flow detected. So let's just quickly discuss what the EGR system is. The idea behind the exhaust gas recirculation system is to recirculate at times, when the engine conditions are correct, literally exhaust gas back into the intake to be burnt. Why would you do that? Well, what that does is it reduces the temperature, the combustion temperature. So this actually benefits performance and helps emissions. So it's actually one of the few systems that you shouldn't turn off or disengage. It actually helps the engine performance-wise and emissions. It reduces the NOx emissions out the tailpipe. So what we did is we used the scan tool to control the EGR solenoid, which then uses vacuum, turns on or allows vacuum to go to the EGR valve to open or close it. We opened it, and when it happens at idle, the car should start to shudder. It should start to have problems idling. And it did do that, no problem. Right on key, back it off, it idled solid again, opened it up by percentage, and it started idling rough. So at that point, we knew the solenoid, the valve, and the passages, seemed okay. So then we moved on to the DPFE sensor. We wanted to learn more about the DPFE sensor. So in our scan tool, there's a component diagnostics helper, and we went in there and looked it up, and here's what we learned. High-level description. Its job is to sense flow when the EGR valve is open. So in other words, it's one of those self-checks that OBD2 proposes of each of these OBD2 systems that help in emissions, that they must check themselves. And this is what the sensor that helps test it. And I just wanted to show on his truck, it was the old aluminum casing DPFE. He couldn't find, they don't make those anymore, so we went with a plastic one. And you can't tell here, but there's actually 2 ports here and 2 ports here. And it has 2 ports, and they're named high and ref. So what it does is, I made a rudimentary diagram here. So you have the intake manifold, the EGR valve, the DPFE sensor right here, and ref and high. And there's an orifice here which causes the Venturi effect. So the exhaust gas is going to slightly be over 1 psi. So it's going to be a little higher than the current atmospheric pressure, right? So when that valve opens, it's going to allow that exhaust gas up, right? Because the intake and a naturally aspirated engine would not be above atmospheric pressure. So there's a pressure delta, so the exhaust gas is going to want to go and equalize, so it goes up into the intake, and the DPFE is making sure that flow occurs, and that orifice allows that to be detected. Well, what else did we learn? Now that you know how the sensor, its high-level job, how does it actually do it? It's a potentiometer. We have more information on my website about potentiometers if you'd like to learn more about those. Those are very, those appear frequently on the car, like, for example, the DPS, throttle position sensor, is a potentiometer. Anyway, it has 3 pins, V reference, 5 volts. It has a PCM ground and the signal wire. Signal wire is what the PCM is seeing what the DPFE sensor is sensing. And the spec is when the engine is key on, engine off, it should read the signal wire, when you're back probing it, should be at 1 volt. So what this screen represents is what the test that I executed. The key on is engine off, and I back probed these 3 wires on the DPFE. And the scan tool, meaning what the PCM is reading, is 4.93. And then what I read on the back probing is 1 is 5 volts, and if you remember that's 5 volt reference, that's right. 2 is ground, and it's at 23 millivolts, which means that's a voltage drop test, right? Because the circuit is there's current in the circuit, so it is a voltage drop, and that's very good for a sensor. Usually you want like max of 200 millivolts, so 23 millivolts is really good. And then the sense line was 4.93. So at that point, I knew circuit integrity was good because I'm back probing the sensor, it's 4.93, and the PCM is reading 4.93. So we disconnected the sensor, and I read number 1, and it still said 5 volt, which makes sense, that's 5 volt reference. And then I checked pin 3, which is the signal, and it was 4.93, and the scan tool still displayed 4.93. So what that indicated is the PCM is using a pull-up type circuit configuration, a pull-up resistor, to pull that up. Not sure why it's not 5 volts. I don't know the internal design of the circuit, but clearly since it didn't go to 0, it went to 4.93, which is very close to 5 volts. It's a pull-up resistor type of circuit. So at this point, I knew the circuit integrity was all good, but my friend still had a little bit of doubt. Because when the previous owner of the truck installed a new clutch, they pinched the wire harness, the wiring harness. So he wanted me to, prove it even more. So what I did is if you remember, the scan tool displayed 4.93. I took a test light, one side of the test light hooked to chassis ground, and then I touch the signal, so that's going to pull down that signal to 0 volts, and that worked. The DPFE PID went to 0, so we knew at that point that circuit integrity was 100,200% on that. So he was satisfied with that, and we knew the sensor was bad. So a couple weeks later, We installed a new DPFE, and using the scan tool with key on, engine off, I brought up the PID and it displayed 1.04, so we knew it was a fixed. And then we again ran key on, engine off, full self-test, and no DTCs were displayed, meaning the EVAP system was most likely resolved, and now it's almost 2 months since this fix. That has not come back. So we knew the EVAP system was because of the gas cap. We got lucky on that one. And the EGR was due to the DPFE. So we considered all of these a fix. Thank you for watching. I hope you found the information helpful.